All righty. Long day after lunch. This is kind of a nap time. Not. I'm going to keep you awake. But we have a couple guys here. We're going to talk today. We're part of the Cooling Environments discussion, open discussion. And I have John Musilli and John Gross. And I'm Don Mitchell. And we, for the past year, have been participating in a program called the Advanced Cooling Facilities. And for those that were on early this morning, we kind of went through some of the change that went through. We have other member who is actually right now, John Minash was going to be on this call, but they have a data center facilities call right now where we're doing that. But as you may recall from this morning, we have a new program coming down. For the past year, we had this program called Advanced Cooling Facilities, which was looking at the concept of adding liquid cooling to data centers. And we have these concepts of the immersion cold plate or advanced cooling solutions, which was immersion cold plate and rear door heat exchangers. And we were trying to pull them together. We now have a new program announced this morning where we're having a cooling environments track. And there's three areas that you've already talked to: the door heat exchangers, the darn it, Microsoft is trying to teach me how to use PowerPoint right now. So anyway, door heat exchangers, immersion, and advanced cooling solution set. So what I'd like to do.
That's playing on the screen right now.
So why is it doing
that? Subtitle across the bottom.
How do you turn that off? I love you guys. It just popped up and I tried to get rid of it and it went away. Okay, so for the hearing impaired, you now can read what we're going to be talking about. This will make there we go. This will make the presentation a little more entertaining. But first off, let's talk about why this program came into view. Why did we have advanced cooling facilities? John, Mr. Gross, Mr. Musilli.
Yes.
Give me, what was the impetus? Why did we actually have to have a program called Advanced Cooling Facilities? What brought us on board?
I think, my background was Intel Corporation, so I had an opportunity to work with a lot of hot processors over the last 10 years and got exposure to things that were in the 400, 600, 800,000 watt processor capacity. And so immersion, or at least heat, collecting as much heat as you can and dumping as quickly as you can, came into the environment relatively early in 2014, 2015, at least at the lab level, and understanding that. The processors themselves were able to be throttled a little bit and some controls, but we need to find a way to collect as much heat as we can and move it to another area to dump it or reuse it.
Yeah, in my background, I'm a consulting engineer doing facility design, infrastructure design. And so I've been working in the liquid-cooled marketplace for about 13 years now with a lot of energy companies and HPCs and whatnot. And one of the things that has been an ongoing battle for design consultants and quite frankly for owners as well is we're kind of in a area right now or a time frame with liquid cooling that we were in with air cooling a couple of decades ago, where every manufacturer kind of has their own form factor, they have their own requirements. So basically every single installation is somewhat unique and custom, and it makes it a lot more difficult for owners to have a plug-and-play type infrastructure. And so part of the idea behind the ACF workstream is to try to drive alignment of the industry so that there's more modularity.
So appreciate that. Going forth on what we're going to be talking about this afternoon, we started talking about here. Our discussions here are going to flow into this discussion on we're going to have a panel discussion on liquid distribution guidance and best practices. We're going to have a panel discussion on risk and reward, how to mitigate liquid cooling concerns. We're going to have another discussion on guidelines for standardization of liquid-cooled ITE. Then we're going to have a discussion on how do you actually get liquid-cooled IT in and out of the data center. All these are facilities-related discussions. And then finally, there's going to be a discussion on do you really need to have it connected to the, do you have to have liquid cooling IT connected to your cooling solution, or can you just have a way to just evacuate it via the air-based solution? So as we go through this, let's start out with one of the key questions here. Years ago, a guy, Kevin Brown, I used to work at a company called Schneider Electric, and many of you may have heard Kevin Brown about 2013 said liquid cooling is the vision of the future, or is the cooling method of the data centers of the future, and it always will be. Give me a couple reasons why that was true back in 2013, or may have been true back in 2013, and why it's not necessarily true today.
The 2013, so he could see the future, at least from where he was sitting, probably clients that he was dealing with, is what I'm guessing, back to the same chair I was able to occupy at Intel, that you knew we had to do something different in the next 10 years, because by 2025, the scales that Intel used to have, they had a 1-year, 3-year, 5-year, and 10-year model. And by 2025, there were no known solutions in the air-cooled space. So liquid became a natural. Personally, I prefer immersion over plates and other discussions, because you got to get there anyway.
Right.
But I defer to the plates because it's the same infrastructure, so I can just move from the plate environment to immersion from a design standpoint.
Yeah, and from my perspective, I think a lot of it is that you know, there's so much inertia in the air-cooled environment. We've been doing air cooling for so long. People are comfortable with it. They're used to it. And so every time the industry got to the point where the end user was calling for more performance and more performance and more performance, the industry would figure out another way to get the compute performance requirement out of the hardware without actually driving the TDP of the chips up. And so it seemed like every time we started talking about liquid cooling is going to be the next thing coming, then the industry would respond with, yeah, but we figured out another way to do this without raising our TDPs. And I think, you know, why it's not true now is, you know, back in 2019, I think Intel was really the first chip manufacturer to kind of admit, okay, if we're going to get the performance that everybody's asking for, we've got to cross that magical TDP threshold of about 150, 160 watts a chip, and we're going to be dealing with liquid-only SKUs on our chips. And once those products were released, that kind of started opening the floodgates.
So interesting points, kind of summarizing a couple of those and maybe throwing something else in there. Back in 2013, air was easy, relatively speaking. We found ways to work with it. The perception of reliability versus efficiency. In all honesty, there was a perception of reliability being less with liquid, or may have been, and that there wasn't a perception of the efficiency advantage back then. There weren't standardized methods for adding liquids. There weren't as many solutions as we have today. And John Musilli has worked with liquids inside data centers for years. I didn't give some of his background, so was John Gross. But John Musilli was with, you were with Intel data centers.
Yes.
You ran liquids there for a while.
So we added liquids to the data center and overhead cooling solutions, pipes and everything in 2013, 2014. I mean, there's no real reason to be aware or afraid of the liquids in your data centers. I mean, there's liquids all over that space that you may not be aware of just because they're hidden in the walls or in other ceiling infrastructures. But it's just a way to manage. You just have to manage it, just like any other engineering problem, just manage the liquids. So liquids in a data center are not a problem overall.
So adding to that, today, what John Gross said, air is not easy. There's a lot of solutions coming out where air can't work. Just point blank, air can't work. So air is not easy anymore for some solutions. For some solutions it still is, but it's not always true.
Yeah, and a lot of that's driven by the workload. And I think one of the key things that maybe some people in the room have caught on to, maybe some haven't, back in May of this year, ASHRAE TC99 published version 5 of the thermal guidelines. I've been fortunate enough to be part of that committee for the last couple of years. And one of the big changes that came out in version 5 is the addition of a new air class called H1, which is for high density air-cooled ITE. And one of the first things that you notice when you look at the bounds for that H1 class is that all the temperatures, both the low and higher end, et cetera, are lower than they are for the A1 class, which historically has been the coldest air class out there. So ASHRAE is even coming out saying, yes, we can go higher, but we've got to go colder on our air to do that, which goes counter to what everybody's trying to do, which is run the air hotter so that we can maximize free cooling economization, et cetera, et cetera. And those thermal guidelines, that H1 class, actually came from collaboration of the ITE manufacturers, the AMDs, the Intels, the Dells, and the HPEs of the industry. They actually wrote that guideline.
Yeah, that probably came around because the workload being done was pushing temperatures above 40 degrees delta T across the server. So they had to start somewhere so they could end within an infrastructure that was known to the environment.
Yep.
Yep. So great summary again. Air is not easy necessarily. Sustainability and efficiency have shot up. And just in the past year, and you heard me talk about this earlier at several different discussions, last year we were looking mostly at adding capability of doing high density. Now we're also getting this wind of sustainability is very important. And if liquid cooled IT actually adds to your sustainability equation, that's great. And then the other aspect is there's just a great number, as you walk around these halls, the number of solutions of liquid cooled IT have gotten better. And so what you're going to hear in later discussions, we're not going to have time right now, is we're going to talk about the concept of using reference designs and driving down the one big factor that many people bring when you do these discussions is cost. And so what's the concept of cost? Is it more expensive to do liquid or not?
My experience designing the systems is it's very density dependent, right? And the density that you have in your data center is going to depend on your workload. Typically speaking, the higher the density, the faster the liquid cooling solution makes sense. And there gets to be a point as you go up in density where your construction cost, which everybody has assumed for a long time, the construction cost for liquid cooling is higher than it is for air cooling. But once you start getting up into the 30, 40 kW per rack range and higher, a lot of times your construction cost is actually lower for liquid cooling than it is for air cooling, plus you have the energy savings and the sustainability on top of that. So you're not looking at an ROI, you're actually cash flow positive from day one.
Fantastic. So just doing the right thing and doing it repeatedly is a good way to doing this. We're going to be covering that a little bit more. What you're seeing up here is a discussion, don't fear liquid cooling, plan for it, or plan for IT. And the general theme of the OCP and advanced cooling facilities has been to do just that, to not fear something, but to plan for it. But in the process of doing that, one of the key things to look at is why do people have fears? And in many cases, fears are irrational. I'm surprised my two co-speakers with some pictures they may have seen recently, but didn't expect I was going to put up here. Oh. So you want to talk about how these might apply to why you'd have a fear of liquids in your data center.
There's a slight chance in that first one that the integrity of the gasket might be compromised, or maybe the clamping force of that flange. But yeah, despite everybody's best intentions, through design, through manufacturing, through product development, so on and so forth, everything comes down to execution in the field. And you have to be careful about not only planning correctly, but also executing on the backside to make sure that everything is installed as designed to maximize that efficiency and maximize that safety.
So proper installation is key to everything, and it's especially key to liquid cooling. And that's one of the things we're going to pick up later on in our next talk is going to be how do you verify proper installation? What can you do in reference designs and doing the same thing over and over again so people recognize what a proper installation is one way to do that. John, do you have something else? Mr.
I'm not familiar with that picture in the blue there, so I can't comment on it.
The picture in the blue, actually, you don't have any idea?
No, I can't, not from my angle.
So what you're looking at there is a pipe that has condensation on it.
Oh, okay.
You want to talk about what is condensation and why do I put it on this page as being a concern?
So condensation is not really a nemesis. It's a well-understood activity inside of data centers. You have dissimilar temperatures of fluids and airs. And essentially, it's what happens on the side of your glass when you have ice in it and ice water. Well, it happens to your pipes also, but the pipes, you avoid that condensation dispensing from the pipe or moving from the pipe by putting insulation around it and keeping the pipe roughly at the same temperature as the fluid. But once the pipe temperature changes and certain climatic conditions come into the room, you're going to get moisture on there and it's going to collect. It's going to travel down the pipe like water and gravity want to do, and it's going to drip off and look like a leak, but it's not a leak at all. It's just poor installation.
Yeah, and I think on top of that, to add to that piece, a lot of times folks will go out there and they'll look at existing piping systems or look at chilled water systems. They'll see stains, they'll see discolorations, they'll see indications of what they believe are leaks. And in fact, those aren't leaks of water leaving the pipe. What they are indications that the vapor barrier of the insulation has been breached, and you have condensation forming underneath the insulation. That condensation is making its way out. And so one of the concepts that we'll expound upon later in one of the follow-on conversations is the concept of the operating dew point temperature of the air in the space relative to the operating liquid temperature in the piping network.
Yeah, so going back to this slide, what you're seeing here is in a slab floor environment, if you're gonna add liquid, where are the pipes gonna go? And the answer is they're gonna go up above. And if you have a dripping pipe from up above, most of the people in your building will think you have a leaking pipe. The engineers will come to you and say something like Mr. Musili or Mr. Gross said, technically that's not leaking, it's just dripping. But the outcome ends up being the same. The people that own the data center say it's a leaking pipe. And the reality ends up being you can design around that. And we're gonna talk later on, just having your liquids at a higher temperature means you don't have condensation. And a lot of the myths, and that's the next thing here, a lot of the myths die once you actually take away the cause of the myth. So the liquid cooling mythology, they heard it from a friend, you heard it from a friend, you heard it from a friend, you were leaking, okay? Versus liquid cool reliability science, and that's one of the things we're looking at is if you do, there are scientific methods, the electrical industry has used them for years. A lot of the liquid distribution methods are art-based. They depend on your skills or the skills of someone who installs it. And so if we can move more toward the electrical world where you have MTBF and reliable and repeatable methods and away from the, we hired Michelangelo to do our welding and he can't work today, so we got Bubba. That world is something that is where we have to transition to make the data center skill independent. And these other terms I have here, the FMEA, MTBF, SOPs, and MOPs. Mr. Musili, you want to touch that, or Mr. Gross? Which would you like to?
Go ahead, John.
Well, so, FMEA and, MTBF are the scientific methods of determining what the likelihood of a failure is, as well as what the impact of such a failure is. And from a practical standpoint, when you look at most data center design contracts, the design engineers are not actually being paid to do detailed FMEAs on every single component of their design. Usually those types of things will happen on new design concepts, but fundamentally we're talking about using best practices, known best practices, such as, if you're gonna have piping overhead in the data center, whether you're concerned about a leak, whether you're concerned about condensation or not, don't run the pipes over the top of your power distribution gear or over the top of your servers, and the chances of you actually having a water-based failure go down substantially. So that's a risk mitigation strategy. But the MOPs and the SOPs become very, very key in the conversation, because if you look at a lot of the studies that are done by Uptime Institute and other organizations, one of the things that is frequently brought up is that the lion's share of failures in data centers happen due to human error. And so your MOPs and your SOPs, your method of procedures and your standard operating procedures are documents that need to be developed during the course of design, construction, and commissioning to help bridge the gap between what the design engineer had in mind when the facility was being designed and what information the operations team is going to have at their disposal in order to do planned maintenance or do emergency operations in response to those. Without those documents, your probability of a human-based failure goes up dramatically.
And then also to the point we made earlier about fluids are all over data centers already. They're in your fire systems, they're in your roof drainage systems. If you have any restroom facilities on a second floor, third floor, your multi-story building, there are fluids everywhere. Engineering knows how to manage the fluids. It's really the perception that the fluid gets into the data center. And you could put barriers in your roofs and in your ceilings and around your walls to protect for that if you can't get away from or mitigate the risk above you. But there are fluids that have been managed for thousands of years. And
Fantastic.
Managed for the next 1,000.
So kind of tying this together a little bit, you're going to hear stories from me when you see me later on this afternoon. I used to live inside a welded pipe. I was on the USS Bluefish. And so I have studied pipes from the inside out. I would tell you that perfect design is not possible. Our subs are exceptionally well designed. And what we end up having are very strict and standardized MOPs and SOPs. And so you can take somebody who, you have these classes of submarine, and someone can go from one sub to another sub, and literally, without knowing what the hull number is, he can actually do the MOPs and SOPs for every sub in his class. And if we start getting OCP in that direction, where we actually have standardized methods of doing things, we'll never quite get to the same class and concept, but we will get closer to a point, and that's why we don't lose submarines, because we have a repetitive MOP, SOP that we learn from, and that works with standardized design. But fundamentally, there's two things to work from there. Number one, use science wherever you can to drive out defects, and number two, have the MOPs, SOPs, and EOPs, because there's certain processes that will always have a certain amount of risk, but you can eliminate that risk just by having a trained crew to do it. So kind of looking over some of these aspects here, we kind of talked briefly about where you're going to run the pipes, and that's a challenge. We're kind of toward the end. This was just supposed to be a introductory call or discussion. We're leading into several discussions later this afternoon. What you're looking up here is some of the choices you have on where you can run a pipe. And for those who've been around data centers a long time, you might be familiar with, say, a raised floor environment. But those, in many cases, are not the standard, or as much the standard. They still happen, but they don't always happen. You went out to the floor today, and you might have seen some immersion vendors are integrating liquid distribution as part of the rows of their racks, or part of their tank solution. So in essence, you don't have a liquid distribution issue at all. It's part of the solution that's delivered. You just have to get it one point into supply. You see some other, there's a dual phase immersion cooling in the middle there that also integrates liquids as part of their rows of racks. And the final aspect ends up being, in some cases, neither of those work, and you have to run the pipes overhead. And so that's where applying those principles of science, FMEA, MTBF, and MOPs and SOPs. You don't put your valves right over your rack, you put them in a place where you don't put your strainers right over your rack. And you have liquid collection where you need liquid connection, but you don't over-design. That's what we're going to be covering this afternoon. There was briefly some discussion earlier today. We're not going to have time to, but the Advanced Cooling Facilities is also looking at, and you've heard this before, integrating heat reuse is one of the outcomes of the reference design concept. Final aspect is our call to action. And we have weekly calls on Tuesdays, and we are looking for participants both to help continue the maturity or maturation process of the work streams that we already have, as well as to help develop a work stream around heat reuse and global opportunities and success stories. And if you want to join these groups, the easiest way is just go onto the OCP webpage and subscribe to our calls. And we have, like I said, global calls, and then once a month I usually try to contact Asia Pacific and see what they're thinking, because for some reason they don't seem to like 8 a.m. Pacific time.
So we have just a couple minutes left. Are there any general questions or specific questions that we could answer in less than 3 minutes? Well, let me ask some questions. So is anybody planning on using liquids in their data centers outside of the traditional cooling system today, air-cooled cooling systems? Either cold plates or immersion or rear door heat exchangers? No? Okay.
Just have some attendance. It's
Well, that's good. That'll be good, because that's why the OCP paper will be good, because you could take that paper and you could go and put it in your data center next month.
Well, so, and that's to his point, I literally on Friday was contacted by a major financial firm, and the major financial firm, I know as of a year ago, had no plans to add liquids in their data centers. And they called me on Friday, and the head of the design, and said, we're going to need to be adding some immersion to our data center. I need to join your team, because we need to figure out how we're going to plan for this. Now, the key thing, we've also had people participate on our call that have talked about doing hot tap in a pipe system. I don't know, has anyone ever participated in a hot tap so the Amazing Jack, was it a fun experience? Hot tap, for those that aren't familiar, you have a pipe you haven't planned to add a liquid to, so what you end up having to do is add a valve to an operating pipe. And so you basically weld a valve on top of that, and you cut a hole in that, you catch the coupon before it drops in the pipe, and then you finish the cleaning it out and welding. But during this process, welding in an operating data center, I should show you the video. You have flames going around, you have smoke, and then you have all this shrapnel and the filings that fall inside your pipe. And that doesn't have to happen if you plan ahead, and we'll talk about this later on in our next session. We're going to give some tips on how to make it so you don't hot tap in a data center.
Did we have a question over here? No? Okay.
So that's all we have for this moment, and I think we're coming back in about 10 minutes.
Okay, thank you.
Thank you much.